Hello friends, last class we have discussed 11 examples from level 1 and level 2. Remaining examples let us discuss in this session. So let us begin with example number 12. In this example number 12, it is given that given informations are E1 and E2 are eccentricities of the ellipse. Then the first equation is equation of a ellipse. It is the first equation of a ellipse. Second equation is it is a equation of a hyperbola. Then E1 and E2, it represents eccentricity of a first one ellipse and eccentricity of a hyperbola E2 it is. Then using eccentricities we have to find the value of a k here. So very simple. So first I will use a formula of eccentricity of a ellipse it is. So first it is a ellipse. It is a eccentricity is given by under the square root of 1 minus it is a b square by a square. So b is 4, a is 18. So I write this as 4 divided by 18 it is. So further I simplify, it is a divisible by 2 table, 2 2s are, and here 2 9s are here. So we are going to get this as under the square root of 1 minus 2 divided by 9. So I simplify this. So E we will get it as a root 7 divided by root 9. We are going to get it as a 3 here. So this is a ellipse 1, E1 it is. So E1 we have calculated. Eccentricity E1 it is. Similarly, we will find the second eccentricity of a hyperbola. It is given by the formula. So I am taking a notation as a 2, E2 it is. So under the square root of, see, I told you the difference between a eccentricity of a ellipse and hyperbola. In a ellipse minus, in a hyperbola plus, it will become 1 plus. So b square 4, a square 9 it is. So we are going to get a 4 by 9 it is. Then we will take a LCM. So 9 plus 4, 13 divided by 9. So we are going to get this as a root 13 divided by root 9 is a 3 here. So we get a eccentricity 2. Then further it is a given E1 comma E2. It lies on an equation that is a point of the ellipse. So it is a 15 x square, it is given in a question, plus 3 y square equal to k. So now x we have to take it as a E1, y we have to take it as a E2. So the below equation will become as 15 E1 square plus 3 E2 square equal to k. So E1 and E2 value we know. So we will substitute. So 15 E1 is root 7 by 3, squaring that. So we are going to get it as a 7 by 9 it is. Then 3 E2, it is a root 13 by 3, squaring that, 13 by 9 we are going to get it equal to k. So if we simplify this, k value we are going to get it as a 16 here. So k value is a 16. Therefore clearly option D is a right answer here. Option D is a right answer. Like this we have to simplify. Now dear students, so single correct option, JEE advanced questions will solve it now. So the curve described parametrically, I told you x and y, if it is a third variable is defined, then it is called as a parametric equation. So in this we have the two equations. So we'll note it down that. So x is, it is a t square plus a t plus 1. Another equation we have, it is a y equal to t square minus t plus 1. I call these equations as equation 1 and equation 2. Then so I will subtract equation 1 and equation 2. equation 1 minus equation 2, t square get cancels, will get a solution for a t, that is we are going to get a t solution as it is a x minus y divided by 2, we get it as a t here. Similarly, equation 1 and 2, I will add it, plus t minus t get cancels, will get a solution for a t square. Okay, so that is x plus y divided by 2 equal to t square plus 1, we are going to get it. When we will get this? So very simple, when we will perform equation 1 plus equation 2, we are going to get this expression. Now so earlier equation will substitute the value of a t, so we will eliminate t from this equation. So it is a x plus y divided by 2 as it is equal to t square. So I am taking a t value as this, squaring this value, x minus y whole square divided by 2 square is 4 plus 1 here. So here the LCM is a 4. So to avoid a LCM, you can multiply the highest denominator, that is multiplying by 4 or multiplying by this LCM. So we get 2 ones are 2 twos are 1 2 get cancels, x plus y, 4 4 get cancels, we get a x minus y whole square plus 1 into 4 4, we get it. So we will observe that it is a perfect square. It is a perfect square. It is perfect square. Therefore it will represent equation of a parabola here, equation of a parabola. Therefore option A is a right answer. It is a perfect square, therefore option A is a right answer. Okay, we'll move to a next example. Here the point P and a point Q are given, where theta and psi or phi, theta and phi, they are related by theta plus phi equal to pi by 2. B, 2 points on a hyperbola. So hyperbola standard equation is given. If h comma k is a point of intersection of a normal at a P and Q, then we have to calculate the value of a k here. Okay, so like this we have to calculate here. Okay, so I take the standard form of a hyperbola. Already it is mentioned, I am taking that. So it is a x square by a square minus y square by b square. We are going to get it as a 1. Then further, see, point P is a given. Point P is, it is a sec theta, b tan theta. Then we'll find which is a normal equation n1. So I have already discussed equation of a normal. In that, substitute these values, we are going to get it as ax cos theta plus by cot theta equal to a square plus b square it is. Yes, so this is a first normal, and second point we have, it is a sec phi b tan phi. So I represent this as a second normal as a n2, as it is a ah sec phi it is, so normal it will become as a sin theta plus bk tan theta equal to a square plus b square. So I call these equations as equation 1 and equation 2. So further, using these two equations, we have to eliminate h. So RHS are same it is. In these two equation 1 and 2, RHS are same. So LHS we have to equate and we have to eliminate h. So we have to eliminate h. Eliminate h. So eliminating h, we are going to get this expression as bk is multiplied by cot theta sin theta minus tan theta cos theta equal to a square plus b square is multiplied by sin theta minus cos theta. We are going to get this one. Then simplifying this expression, so tan as a sin by cos like that, so and a cot as a cos by sin, so simplifying we'll get a k value as it is a minus a square plus a b square divided by b here. So this is the answer we are going to get it. So option D is the right answer here. Minus a square plus b square divided by b, we are going to get an answer. So this is a correct option. Okay, we'll move to a next example. If x value is given 9, the chord of a contact of a hyperbola x square minus y square equal to 9, the equation of a corresponding pair of a tangent is. So if it is h comma k is a point, then its standard form is given by xh minus yk, and here they have given a 9. I am taking a 9. So by comparing here, so already some values we know. X equal to 9 it is. X coefficient, so just compare it. 1 we are going to get it. So here y coordinate is missing, x equal to 9, so k is 0, we can take it. So just I have compared, so this equation with x equal to 9 here. Very simple. X coefficient is h, so x coefficient is 1, so h equal to 1 I have taken. So y is missing in that equation, so k is nothing but a y coefficient, so y is missing, therefore I have taken it as a 0. Then h comma k is a point here. H comma k is a point, so that is a 1 point. So h, it is a 1, k it is taken as a 0. Then pair of a tangents, so equation I am taking pair of tangent, pair of a tangent it is given by s1 equal to t square. So yes, from a standard equation we are going to get this as x square minus y square minus 9, so it is a given here. One more, x, so it is a multiplied by, so x it is a 1 here. Just compare here. Here I am putting a box over here. So 1 minus y square is 0 minus 9 equal to, it is t square, tangent square, x minus 9 whole square. So this we get it. So simplifying this one, so we are going to get this as x square minus y square minus 9, so is multiplied by 1 minus 9, it is a minus 8 equal to, it is a expand it, we are going to get a x square minus 18x plus 81 we will get it. So if you simplify LHS and RHS, so we get equation as 9x square minus 8y square minus 18x plus 9 is equal to 0. So we will observe that, so almost all options are same values only, just they are differ by plus and minus sign. So clearly observing, we will observe that. So option B is the right answer. It is plus minus minus plus here. So option B is the right answer. So very close answers are there. Okay, we'll move to a next example. The equation of a common tangent to the curve, so y square equal to 8x and xy equal to minus 1 is, so tangent to the parabola, see tangent to y square equal to 8x, which is a parabola. Tangent to parabola is given by y square equal to 8x. Then we'll take equation for this. So y equal to mx plus, comparing with the standard equation, y square equal to 4ax. So a value is 2. So we are going to get a 2 divided by m. So we call it as a equation 1. So it is a given that it will touch the equation. Okay, so it will touch the equation xy equal to minus 1. That means, so they have a equal roots. So point of a contact is the same, therefore equal roots. So x will be as it is, y is mx plus 2 divided by m equal to minus 1. So next, so we'll multiply x to a bracket. So we are going to get this as m x square plus 2 by m into x plus 1 equal to 0. So this is in the standard form, ax square plus bx plus c. So a is m, b is 2 by m, c is 1. So we'll observe that the point of contact is the same, therefore they have the equal roots like this. So depending on the common tangent, common point of contact, therefore see roots are equal. So we'll observe equal roots. So equal roots means you have studied b square minus 4ac equal to 0, or else we can write b square equal to 4ac it is. Then b is 2 by m, so b square is 4 by m square. So 4 times a is m, c is 1. So we'll simplify this. So 4 get cancels, m cube equal to 1. So m we get it as a 1 here. M we get it as a 1. So in an equation we have to substitute equation 1. So 1 becomes so in this equation 1, so equation 1 is this. In this we have to take m as a 1. So we get as y equal to m plus 2 it is. Okay, y equal to x plus, sorry, x plus it is, x plus 2 it is, x plus 2. Therefore clearly option D is a right answer. This is a first page solution and this will be the second page solution. Okay, we'll move to a next example. So given information, we'll note it down. So given the family of a hyperbolas, so equation is, it is a x square by cos square alpha minus y square by, it is a sin square alpha equal to 1. Which of the following does not change with varying alpha here? That is, we have to find abscissa, eccentricity, directrix and abscissa of our vertices. So after solving these things, so it should be, so like does not exist alpha here. Okay, so such quantity we have to see does not exist alpha here. Okay, so that we have to calculate. So using this four options here. So first we'll calculate option A, abscissa of foci here. Okay, so let us begin this. So for this I find a eccentricity. Eccentricity formula is, it is a E equal to, it is a hyperbola. Hyperbola eccentricity is, it is a 1 plus, it is a b square by a square here. Okay, so then, so I square it on both the side, so I get a E square equal to 1 plus b square by a square it is. So we have to simplify these equations. So we get a E square equal to 1 plus, so b square as a sine square divided by cos square alpha a square. Then plus 1 will take it to LHS, so we get a sine square alpha by cos square alpha equal to E square minus 1. Further we'll write a solution for a sine square. So it is a sine square alpha is, cos square is multiplied with the RHS, so we get cos square alpha into E square minus cos square alpha it is. Yes, so we get this. Then this cos minus cos square alpha will transport it to LHS. We get a sine square alpha plus cos square alpha equal to cos square alpha into E square. So we are going to get it as a 1 here, 1 as cos square alpha into E square. So from this abscissa of a foci we have to calculate. So it is a abscissa of a foci is square root of this, so that is cos alpha into E comma y coordinate is 0. So it does not exist here. Therefore clearly option A is a right answer here. Does not change with a varying alpha here. Option A is the right answer here. Like this we have to calculate. Okay, we'll move to our next example. The lines. So first one is a line. It is a given is a tangent to the curve x square minus 2y square equal to 4. The point of a contact we have to calculate. So here we will observe that there is a one curve is there and there is a tangent. So this point of a contact we need to calculate here. So first we'll write a line. Line is 2x plus root 6y equal to 2. I call it as a equation 1. Further we have equation of a curve, that is a x square minus 2y square equal to 4. After this I use equation of a tangent. Equation of tangent I am going to use it. Equation of a tangent is given by, it is a x x1 2y y1 equal to 4. Okay, now look at a equation 1. RHS is 2. Look at this last step equation 4 it is. So equation 1 will multiply by 2, will make a RHS of these two equations as the same here. So I am going to get this as 4x. Equation 1 is multiplied by 2, so it is a 2 root 6y equal to 2 into 2, 4 we get it. Now look at this equation and this equation, RHS are same, so LHS we have to equate it. So we get a 4x equal to x x1 and one more minus 2 y y1 equal to 2 root 6 y here, 2 root 6 y. So further see x coefficient we have to equate it. So x1 we are going to get it as a 4 and y1 we get it as a, it is a minus root 6 here. Therefore these are the point of a contact here. Therefore x coordinate first preference we have to give. For it is y coordinate second preference, it is a minus root 6. Therefore this option, it is there in a option A. Therefore option A is a right answer. So like this we have to find a solution. So remaining examples we'll discuss it in a next session. So thank you for watching this video. Thank you once again.